friends, it is time to finish up these passive transport notes. So we're going to need the sheet from yesterday that had the diffusion and the osmosis on it, and we're going to finish up that bottom right-hand side by talking about osmotic solutions and tonicity. And these are really big words and they sound scary, but all they mean is that there are different types of solutions or different types of like mixtures that we can have in our bodies or that plants can have inside of them that cause osmosis to happen, and it's not good, right? So it can mean that water is going to travel outside of the cell, and it's going to make something happen to the cell, or it's going to come into the cell too much, and then something's going to happen as well. And we're going to talk about each one of those solutions. There are three. So our first one is a hypertonic solution, and hyper means above or more, because like when you eat a lot of sugar, you get super hyper, right? Because that means you have more energy than you used to have. So a hypertonic solution means that our cells in our body are surrounded by a solution that has too many solutes. It has a high concentration of solutes outside of the cell. All solutes are like the molecules. So it could be sugar, it could be salt, it could be oxygen, whatever it is. There's way more outside of the cell than there is on the inside of the cell. So when cells are in this hypertonic solution, the water is going to diffuse out of the cell, and that causes the cell to shrivel or shrink, and that's called crenation. And that's really bad, right? So if I were to go eat an entire birthday cake, which I don't think I could ever do, then I would have way too much sugar outside of my cells, so it would pull the water outside of my cells to try and make that solution even, that ratio even. So on your little sheet, you have your little beaker and you have your cell. I would draw some arrows with the water coming out of your cell so that you know it's going to get smaller. Okay, the water will move out. Next, we have isotonic. So this is actually a good type of solution for your cells to be in because means equal. So that means they contain an equal concentration of solutes inside and outside of the cell. So they're happy, right? There's still water moving in and out of the cells, but not too much, not too little, just enough. So we say that there's no net movement of water because it's just a little bit here and there, okay? So it would be like if I took a water balloon and stuck it in a bucket of water. There might be some water that pass in and out of the water balloon, but the water balloon's not going to get super, super big just by sitting in a bucket of water. Okay. The cells are just going to stay the same size. So just like that balloon, it's just going to pretty much stay the same size. Okay. So isotonic is. And our last type of solution is hypotonic. So if we had hyper that was too much and we had iso that was equal, then hypo is going to mean too little or under. So this means that there is a lower concentration of solutes outside of the cell. So there's more inside the cell, which means that the water is going to diffuse into the cell. So our cells are going to swell and get super, super big, and possibly they could lyse, which means that they could explode and pop. And we definitely don't want that to happen. All right, so that's the end of our osmotic solution. So we have our three osmotic solutions: hypertonic, isotonic, hypotonic. And now we're going to start our experiment with our eggs. And our eggs are going to be like our little cells, and we're going to put them in some solutions, and you're going to try to figure out what's going to happen to the cells, okay? So go ahead and hop over and watch that video and look at the data that we have collected for our eggs and write that CDC for me. You got this.